All right, guys, welcome to the full Unit 5 trig review. So I'm going to start these problems as if we haven't looked at them yet. All right, so the first one says, what is the measure of angle B to the nearest degree? And so to do that, we're going to need to use, because we don't know if this is a right triangle, not necessarily a right triangle, we can either use law of sines or law of cosines. Now, to use law of sines, you need to have an angle and a side across from it, which we do. So we can use law of sines. All right, so number one. All right, I'm going to use sine B over B is equal to sine C over C. And the reason I'm picking those is because in my triangle, I have I have angle C at 40 degrees, and the side across from it is 10. And I have angle B that I'm looking for, and the side across from it is 15. Now it's possible I would have to use A first and then get B, but in this case I don't. All right, so I'm going to go ahead and plug in what I need. So sine B is what I don't know. B is unknown. But lowercase b, side length B, this is B, is 15. And sine C is 40. Whoops, sine C is 40. So sine 40 over side C is 10. All right, we're going to go ahead and solve for sine B. So think about how we would do this. Multiply by 15 to both sides. So I get sine B equals sine 40 times 15 all over 10. And then I want to get B by itself, so I'll sine inverse both sides. And so whatever I got here, right, for sine 40 times 15 over 10, I'll sine inverse that. So in my calculator, I have sine 40 times 15 divided by 10. And then I'll sine inverse that answer, which is 74.6. So to the nearest degree, B equals. So to the nearest degree, B is about 75 degrees. All right, number two. Again, it's not necessarily a right triangle, so we have to use either law of sines or law of cosines. My default is law of sines, but to use it, and remember, we didn't know this, I found it for you guys on the previous notes. To use law of sines, I need to have an angle on the side across from it, and so I don't. So instead, I'm going to go ahead and use law of cosines. So I'll sketch my picture. Okay, so again, there's no way to find G directly. We just don't have enough information. If I try to use law of cosines here, it would be G squared equals F squared plus H squared minus 2FH, and then times cosine G. I don't know cosine G, and I also don't know F. So instead, what I'm going to do is use law of cosines to find this side, F. All right, so that gives me F squared equals G squared plus H squared minus 2GH cosine F. So F squared equals G squared, which is 12, so 144, plus H squared, which is 9, so that'd be 81, minus 2 times 144 times 81, and then cosine 53 degrees. I'm going to type this into my calculator. Let's see what I get. So 144 plus 81 minus 2 times 140. Oh, whoops. Oh, my bad. Right here. I see what I did right here. Woo. Not squareds, but I caught it just now. 2 times f, which is 12, or sorry, g and f, which are 12, times 9. We'll try that again. So it'd be 2 times 12 times 9, and then times cosine 53. So that gives me that f squared equals 95, which means that f is the square root of that, which is square root 95 point whatever is about 9.747. So now that I know that, now I can either choose to do law of sines or law of cosines. I'm actually going to do law of sines. Sine f over f is equal to sine g over g. Again, you can go back to law of cosines if you prefer. I'm going to go ahead and use law of sines because now I have an angle and the side across from it. So sine 53 degrees over 9.75 roughly is equal to sine g, which is my unknown, over g, which is 12. And then think about how we would isolate g here, right? So I'd multiply by 12. And then I'll sine inverse both sides. So I have 12 times sine 53 over 9.75 equals sine g. And again, to get rid of sine, I'd sine inverse. And so whatever this is, I'll sine inverse it. Okay, so calculator, 12 times sine 53 divided by 9.75. And then second answer, 79.4. So the closest answer they have is 79.5. C. All right, next one. It says Myra has a garden and the sundial, so I marked that point S for sundial. The sundial is 4 feet from the birdbath B. So I put 4 feet right there. The flagpole is 2 feet from the birdbath. Now, obviously, this has to form a triangle, so it wouldn't be 2 feet this way. It would be 2 feet some other direction. You could have put it down, up, whatever. I put it up here. So there's the flagpole. And then it says the angle formed at the birdbath is 50 degrees. So this angle is a 50-degree angle. It says a bumblebee flies from the sundial to the birdbath to the flagpole and back to the sundial. So it's going to go from the sundial to the birdbath to the flagpole and back to the sundial. How far will it travel? Well, then we'll have to find the side length and then add up all the sides. So that's what I'm going to do. Number 3. Again, we have a sundial, a flagpole, or sorry, a birdbath, and a flagpole. This angle between at angle B, the angle of the birdbath is 50 degrees. We're missing this side B. We know this is 4 feet. We know this is 2 feet. And we're looking for B. All right, so we're going to go ahead and use law of cosines. Remember, to use law of sines, I have to have the angle and the side across from it, and I do not. All right. So you should get really good at writing the law of cosines at this point. So b squared equals f squared, which is 16, right, 4 squared, plus 2 squared, which is 4, minus 2 times 4 times 2 times cosine 50 degrees. I'm going to use my calculator. Let me just triple check that I'm not off the... No, I'm not. You're fine. Okay. So 16 plus 4 minus 2 times 4 times 2 times cosine 50. That's 9.71. B squared equals 9.715, so about 9.72. And then I'll square root my answer. And I get that B is about 3.12. Okay, so then it says how far does the bee travel? Whoops, 3.12. If he travels all the way from the sundial to the bird bath to the flagpole and then back. So that would be 4 feet plus 2 feet plus 3.12, which is about, that's 6, 7, 8, 9, 9.12 feet. So it would be C. All right, moving along. Let's try number 4. So number 4, it says, what is the radian measure of the angle that subtends an arc that is 2 radians on a unit circle? Let me grab a new sheet of paper. This one's full. Okay, so number 4. And let me just guarantee that we're able to see what I'm writing. Okay, number 4. So it says that the angle subtends, that means that it contains an arc of 2 radians on the unit circle. So I'll draw my unit circle. My unit circle, recall, has a radius of 1. So that means from here to here, the radius is 1. And I have an arc being cut right from here to here, my arc. They told me it is 2 radians, and they want to know what is the angle theta. And so we're going to use the formula that S is equal to sigma times the radius, but we're going to use it in the special way where we're looking for theta. So we're going to use theta equals divide both sides by r, S over r. So S is our radian, which is 2, over r, which is 1. And so the answer would be 2. C. All right, next one. A flag is made from a triangular piece of cloth. One angle of the triangle measures 37 degrees. So I'm going to go ahead and draw that. I'm going to make sure that you can still see my writing. Yes, you can. So I have a triangular piece of cloth. One of the angles measures 37 degrees. I'll put that right here. And the side that meets this angle has a side length of 18 inches and 24 inches. It wants to know the area in square inches of the fabric. So to find the area, you have to do base times the perpendicular height. So I would have to find the height. Unfortunately, I don't really have enough information to find the height directly. Let's see. Since this is a 90, I could use, let's see. Yeah, I would have to find the height. So to do that, I would use either sine, cosine, or tangent, since I have a right triangle. Okay, and so I'd have, let's see, using this angle, I have opposite and I have hypotenuse, so I would use sine. So sine 37 degrees is equal to opposite over hypotenuse, which is 18. And then I would multiply both sides by 18. And so I would have sine 37 times 18, 10.8. So the height is about 10.8 inches. Now to find the area, we're going to use area equals 1/2 base times height. So the area is equal to 1/2 the base times the height. Again, you must have the perpendicular height and base. You can't use like this side or this side. You have to have the perpendicular height and base. So that would be 12 times 10.8. So times 12 is 129.99 inches squared, which is about 130. And so our answer would be C. Okay, next one, number 6. Which expression represents an arc length of 120 degrees angle with radius r? And so we're looking at arc length again, so we're going to use this formula again. So my question is, let me triple check that you can see where I'm writing. That I'm finding arc length, so I'm going to use S equals theta times r. And remember, theta is in radians. This was a common error that people were making. So we need to convert our angle. Our angle is 120 degrees. We're going to need to convert that into radians by multiplying by pi over 180. All right, so look for something that will go into both of these. I see that 60 goes into both. 60 goes into 120 twice, and 60 goes into 180 3 times, and then multiply straight across. This is 2 pi over 3. And so I have S equals 2 pi over 3 times the radius r. And so my answer would be D. All right, which of the following are equal to cosine 225? So one way to do this would be to, as I started to do here, change it into a radian. And the other way is to use your unit circle. So I guess if I have my unit circle in front of me, why wouldn't I just use it? All right, so cosine 225, we're going to go ahead and go to the unit circle. So number 7, cosine 225 degrees. On your unit circle, if we go to 225 degrees, we're right here, and cosine, remember, is our x value. Okay, so our x value right there is negative square root 2 over 2. Now, the thing is that there's another spot on the unit circle where the x value is negative square root 2 over 2. So that's really what we're looking for is on our unit circle, where else is x negative square root 2 over 2? So I already know it happens at 225, but 225 in radians is 5 pi over 4. Now again, if you don't have your unit circle, you could take 225 and multiply by pi over 180. Look for numbers that go into both. I believe 15 will go into both. Let me triple check that. 225 divided by 15. Yes. So 15 goes into both. 180 divided by 15. This would be 15 goes into 225 15 times, and in there 12 times. But look, they still have a common factor, which is 3. So I could divide this by 3 now. So really 45 went into both. So 3 goes in there 5 times, and 3 goes in there 4 times, which is 5 pi over 4, which I already knew it was 5 pi over 4. So cosine 225 is also equal to cosine 5 pi over 4, which I can tell just on my unit circle. However, there are other values where that's true. So let's take a look. So where else is x negative square root 2 over 2? It's right here, negative square root 2 over 2 at 135 degrees. So that means it's also equal to cosine 135 degrees. It is also equal to, well, cosine 135 is also 3 pi over 4. Cosine 3 pi over 4. All right, so which of the following are equal to that? And by the way, they could have said sine of 315. Sine 315 is the same value as well. But they didn't give us any with sine. And so the three that we can choose from, we know that it's equal to 5 pi over 4. It's also equal to 135 degrees. It's also equal to 3 pi over 4. Okay, number 8. Again, we're doing something using this formula for arc length. So it says a customer is in a rotating restaurant seated 35 feet away from the center. So I'm going to sketch that. You get a new sheet of paper. So number 8. So he has a rotating restaurant, so it's rotating in a circle. That's what rotating generally means. And it says he's sitting 35 feet from the center. So here's the center, and he's 35 feet away. And it says how many feet does the customer travel after rotating 7 pi over 12 radians? So I don't know exactly where that is, but he rotates 7 pi over 12 radians. So this is our angle measure, theta, and they want to know how far does he travel along the edge of the restaurant. So he's seated here, and he rotates to there. How far does he travel? So this is another arc length question. How long is this? So S is equal to theta times R. Now remember, theta is in radians, and we are already in radians. So this is equal to 7 pi over 12 times the radius, which is 35 feet. So 7 times 35 times pi divided by 12 is 64.1. So S is about 64.1 feet. So the answer here would be A, 64 feet. All right. This is a very similar question. It's about a minute hand. And it wants to know, it says the minute hand on the clock rotates 5 pi over 6 radians while Steve waits for an appointment. Okay, so here's my clock. There's my minute hand. And so what happens is this minute hand rotates 5 pi over 6 radians, which is my angle measure. But it wants to know how many degrees did it rotate. So all they're asking you to do is to change this from degrees into radians. So we're going to multiply by, this time, 180 over pi. And remember, you shouldn't mix these up, because if you're moving from degrees to radians, you want to have a pi in your answer. And if you're moving from radians to degrees, you want to not have pi in your answer, so those should reduce. And then 6 goes into itself once, and 6 goes in there 30 times. So that is 150 degrees. So my answer would be B. All right, it says which angle is coterminal with an angle that has a measure of negative 135? So number 10, an angle of negative 135 degrees means that I'm going to start here at X and move backward 135 degrees. So I'll end up somewhere over here. All right, so coterminal to that in, it looks like in radian mode. So what I would do, right here we're at 360 degrees. So I would take my 360 and subtract 135, which gives me 5, and that's 5, 2, and 2, 225 degrees. So this angle, this direction, is 225 degrees. But our choices are given to us in radians, so we're going to convert this into radians. So 225 degrees times pi over 180. I know 45 will go into both, so 225 divided by 45 is 5, and 180 divided by 45 is 4, and so this is 5 pi over 4. All right, next one, number 11. Oh, 5 pi over 4, by the way, that would be D, 5 pi over 4. Okay, next one, it says, an angle in standard position, it intersects the unit circle at 0, -1. What do you know about sine theta? Okay, so I'm going to draw that. So on the unit circle, you have an angle in standard position, and it says it intersects the unit circle at 0, -1. So 0, -1 is right here. So that means that it is rotated all the way over there. And then it says, what do you know about sine theta? So remember, sine is your y values. And so therefore, sine theta would be right here. Sine theta equals -1. And so our answer would be A. All right, what is the exact value of tangent pi over 6? So we're going to, whenever they ask for exact value, it's kind of a dead giveaway that you're using the unit circle. So we're going to use our unit circle, and we're going to go to pi over 6. So on my unit circle, I go to pi over 6. Pi over 6 is right here. The coordinate is √3/2, comma 1/2. So √3/2 and 1/2. Now what we know about tangent is that this is my sine, right? Sine is y, cosine is x, and we should know that tangent is sine over cosine or y over x. And so what that means is that this would be 1/2 over √3/2. Then we don't want to have a fraction and a fraction, so I'm going to multiply both the top and bottom by 2. And the 2's will cancel. And so I'll get 1 over √3. And then what we usually would do would be to rationalize the denominator, but this answer actually shows up. It's B, 1 over √3. All right, let's try the next one, number 14. So number 14, it says, given that cosine theta equals 2 over 5, and theta is in the 4th quadrant. So theta is in the 4th quadrant, means that we're over here in quadrant 4. And cosine 2 over 5, we're just going to draw a reference triangle, right? We need to know that cosine is adjacent over hypotenuse. So my adjacent, it would be the 2, which here's my theta. Right? So 2 would go here, and the hypotenuse, which is across from our right angle, would go there, 5. And so now what I need to find is this y value, because they say, what is sine theta? And sine would be my opposite over hypotenuse. And so to find that, I'll need to find that missing side length. So we're going to use the Pythagorean theorem, a squared plus b squared equals c squared, where c is always our hypotenuse. So y squared equals, that's 25 minus 4, 21. So y is the square root of 21. So sine would be opposite, which we now know is square root 21, over hypotenuse, which is 5. All right, number 15. Number 15, which of the following expressions are equivalent to secant theta? Select all. So I'm going to write down some identities that I know. So I know that secant, that 1 over cosine theta is equal to secant theta. So that's one thing that I know for sure. Another thing that I know is that I do see some cosecant in there, so I'm going to go ahead and write all of my identities down. So cosecant theta is equal to 1 over sine theta, and then cotangent theta is equal to 1 over tangent theta. And then also my regular trig functions, tangent theta is equal to 1 over cotangent theta. Let me make sure you can see everything I'm writing. Yes. And sine theta is equal to 1 over cosecant theta, and cos theta is equal to 1 over secant theta. And then the last thing I need to know is stuff about like tangent and cotangent, because like I said, I see tangent and cotangents on here. So tangent theta is equal to sine theta over cosine theta, and cotangent theta is the reciprocal, so that would be cosine theta over sine theta. All right, so now there's a select all that apply. So I know for sure secant theta is equal to 1 over cosine. Let me see if that one shows up. 1 over cosine. It does. It's right here. Number 1. It is not 1 over sine, so I can stop. Cosine over sine. Let's take a look. Cosine over sine is cotangent, not secant. So that is not true either. The next one, cosecant theta times tangent theta. So we're just verifying if this is true. So if I take cosecant theta is right here, 1 over sine. And tangent theta is sine over cosine. Those would cancel, and I would get 1 over cosine. And 1 over cosine is secant theta, so this is true as well. So this one is true. And then we have to verify the last one. Don't be lazy. We don't want to just assume it's not true. And so we have secant theta times cotangent theta. And so I'm verifying that these two are true, or that this one might be true. So secant theta is 1 over cosine.